Dear students, in this video I will explain how to determine the areas under standard normal distribution and also under T distribution. These are the two distributions we have already studied. And calculation of the area under these two distributions is essential for hypothesis testing, where when we fix the level of significance alpha, the value of the areas of standard normal distribution and T distribution corresponding to the selected alpha will be required. So, to explain, just open an Excel sheet. From add-ins, go to Megastat, probability. As you can see, in the continuous probability distributions, we have normal distribution, T distribution, F distribution and chi-square distribution. These are the distributions used for hypothesis testing in general. Of these, we have already studied normal distribution and T distribution. So let me first consider normal distribution. It is denoted by ZA, mean 0, standard deviation 1. And I want the Z value corresponding to 0.05. And first I take 2 tail. I click OK. What you see here is, as you can see, the shaded areas, the areas lower than minus 1.96 and above 1.96. And as you can see, these areas are 0.25 and 0.25 lower and upper. That means 2.5% of the area lie below minus 1.96 and 2.5% above. 2.5% in each tail. 95% of the area lie between minus 1.96 and plus 1.96. Now, if you want this area in one tail, say lower tail, you click lower tail, OK. The critical value is minus 1.64. Minus 1.64 is, that is the area below minus 1.9, minus 1.64 is 5%. That is, when we go for hypothesis testing, if alpha is fixed at 5%, for a two-tailed test, the critical values are minus 1.96 and plus 1.96. For a left-tailed test with alpha 5% is minus 1.64. Similarly, for a right-tailed test, you will see that the value is 1.64. So this is the area 5% in the corresponding to alpha equal to 5% for an upper tail test, as you can see here. Now, I consider again the T distribution. I select a P 0.05. I give 20 degrees of freedom. As I told you in my theory classes, T distribution depends on the degrees of freedom. So if 20 degrees of freedom, 0.05 on both the tails, I give 2 tail, OK. As you can see, T distribution 20 degrees of freedom The critical t values are minus 2.086 and 2.086, 2.5% here, 2.5% here. Now suppose that I want 5% in one tail only. So lower tail for 20 degrees of freedom, okay. The critical value is minus 1.725. And for if I want it in the upper tail, I give upper here, okay. I will get this minus 1.725. That is 95% of the T distribution is below 1.725% for degrees of freedom 20. If you give a different degree of freedom, T distribution depends on degrees of freedom. So naturally, if you give a different degree of freedom instead of 20, something went wrong. If you give a different degree of freedom, it is not active now. Okay, if you give a different degree of freedom, critical values will be different. This is because T distribution depends on what is known as the degrees of freedom. If you take a new sheet, you can give it. That is it. So this is how we calculate area under standard normal distribution and T distribution, and understanding of the area under these distributions is important for hypothesis testing.